Okay, hi everybody. How's it going? Hopefully that assignment wasn't a problem. Did anybody have any questions on the assignment before we move on? I haven't graded it yet. I'm going to be getting to that after the class tonight, and then be grading the next assignment. Um, I'm going to be trying to keep up to those week by week. So, no questions? Any questions on the content from last week? Now, one thing that I noticed I missed is I actually, put a to-do to talk about fail fast and functions, and I didn't come back to it. And I just wanted to talk about that really briefly. It's a simple concept. And the whole idea of a fail fast function is to try to simplify the logic by actually failing the function early. And so if you had a function that looked like, let's say function A, and maybe there's a number that comes in, and a traditional way to write this, where you'd have a single entrance and a single exit to this function. Let's say that you only wanted to do some processing if n had a value between 5 and 10. So I could say if n in 5 dot dot 10, which is actually a nice time to actually bring up the in operator. So you can actually use in to test if something is inside of a range. And we're going to see other places where that's useful. For example, collections, you can use that to say if something's in a collection. But let's say that this is the only condition we want that to be true. Then we might be able to say println do something. And for any other value, we're not doing anything at all. Now, this do something, could be complex. So there could be a lot of logic in there. And now it's nested inside this if statement. So there's some conditions you have to be able to look at while you're doing this function. It really makes the function a little less obvious what it's doing. In this particular case, it's not too bad. You just have the one condition. But what if we had multiple conditions? So what if we had x is an integer and y is an integer? Just to throw a couple other conditions in here. Um, we might then actually have things like if x is in 1 to 10, and maybe if y is in 10 to 100. Now we can start to see the conditions get a little more complex on this, and you have all this nesting. Back when I was first programming at IBM, we were doing everything on a terminal for a mainframe, and we had 80 characters to deal with. We were, restricted to 80 characters. Uh, and even before then, when I was programming on an Apple II Plus, I was restricted to 40 characters on the screen, which was pretty miserable. The problem you get there is the more you nest, the smaller whatever your actual code has to be. So people typically did this uh, as single entry, single exit approach to functions. And this was kind of a hard and fast rule for a lot of people where it's like, you only have one entry, not singe entry. Yeah, singe might actually be appropriate. Um, for a while, people thought that this made a function a lot easier to understand and easier to work with. This was really a response to the goto statement. There's some languages that had gotos in them, and goto made logic really, really tricky to follow at times. When we have proper control structures like we do in languages like Kotlin, that's really not as much of an issue. And so I think that was more of a knee-jerk reaction that people didn't like how goto worked. So they wanted to put some rules in saying you don't go to outside of a function, or you don't go to the end of the function. You have proper logic. So a fail-fast approach to this basically means I'm going to check for things that I don't want to handle and get out as soon as I can. And that really simplifies the logic in this. So I could say if n not in 5 dot dot 10, return, something like that. And I can do the same kind of thing for x and y and put those same conditions in there and do something like this. And then notice how all these guys here are coming up saying, hey, this is always true. This is always true. This is always true. So you don't need those. That actually becomes redundant. And now our logic looks more like this. And let's say fail fast A. And I find this quite a bit more readable, especially if you're just checking bounds or checking some kind of conditions on the arguments coming into your function. This is a really nice way to handle this. Now, if there's a return value on the function, obviously you're going to return some value instead of just getting out of the function. But if it's a matter of not doing stuff in the function because of something, you can do a return. So this is one form of a fail fast. And whoops, let's throw another one in here. I'll call it A2. Alternatively, we could have this throw some exception. So maybe I'm just going to throw runtime exception for now. Later on, we'll talk more about exceptions. N is bad. And it really depends on the style of programming that you're trying to do here. If you wanted to treat it as an error when those values are coming in, you're probably going to want to throw exceptions or have some kind of an error code coming out of this function. We'll talk about error codes another time. I'm going to make a note of that because I really want to talk about not error codes, but result objects. And it'll probably come up naturally at some point, but I just want to make a note to make sure I cover that because it's really cool stuff. And it's an alternative to throwing exceptions. So something like this also gives you that same kind of fail-fast capability, but in this case, it's you're actually treating it as an error as opposed to treating it as an ignore. So just something I wanted to bring up here. And one thing to note here is this not in is actually kind of nice because instead of having to write something like not boom n in that return, which will work. You can do that, but you'll notice how it has squiggles saying, hey, you can simplify that with a not in. The operator itself actually does that. It takes care of reversing the operation. And there's several functions that work like this that we'll see that actually talk explicitly about the negative case. So your code is a little bit more, a little easier to read. And this is way nicer than if you wanted to actually test for the conditions explicitly. So if in this case, it'd be kind of hard with because you're talking an integer, you'd have to go from, if n is less than 5, let's just do it this way. So if n is less than 5 and n is, whoops, let's do my logic one, or n is greater than 10. And you could do that. The thing is that this statement here isn't quite as obviously mappable to this check here that we had before. You have to really think about it to revert that one. And this one isn't too bad. I mean, having this range here isn't too difficult, but simply having this not in and using the exact same range is a lot more clear of what you're excluding. So I'll say, a little, oh, come on, wow. Less readable conditions. There we go. So any questions on that? It's just a concept I'd like to talk about. It's an alternative style for writing things, but if you're really, this is especially useful if you're checking parameter values coming in. And there's some other options you can use inside Kotlin for things like this. I'm just going to give you like a little preview of it. And I'm not really sure if it's going to come up later, but we'll see. They actually have a function that'll help you here. And it's called check. And what this check function does is you can say check n in 5 ... 10 and then have a n is bad, something kind of like that. And notice how that's redundant with this next one. It's actually being able to check that, and that's actually kind of cool. What this check function does is it says, let me evaluate this Boolean expression, and if the Boolean expression isn't true, throw an exception saying that n is bad. And that's actually really a nice syntax for this. Um, and it reads a little bit more functionally rather than having an explicit if statement, explicit throw. Um, the way this works is this lambda is only going to evaluate whatever this expression is if the condition is false. So if there's something more complex you need to do here, as far as the check is concerned, maybe looking something up or sending something across a network. In a case like that, the n is bad or whatever that expression is wouldn't be evaluated unless that check is true. And the same goes through here. Obviously, is like this throw isn't going to happen unless that is false. So this check I think is kind of nice. There's also a check not null, which will help for situations like that. But it's a similar type of thing. Just keep in mind that this is actually saying this condition has to be true to keep going. Otherwise, it'll fail out. And I'll do the same kind of things for X and Y. And I'm going to show you a bit of code that this actually does. Let's take a look at this check function. So I'm going to hold down my control key and click on check. And I just want to talk about what is going on in this function from this contract here. This is a special feature inside Kotlin where this contract is basically saying something holds true after this function has been run or after a certain condition of this function has been run. So in this case, this guy is saying if this function returns, then whatever this expression is assumed to have its value. Now this may seem kind of obvious, right? But this is telling the compiler that, hey, after we get through this function, this value had to have been true or false. And that allows this function to, whoops, where was the one that I was dealing with here? Which file was I in? Oh, I was in the wrong file. I'm going to make a copy of that. Fail fast. And then I'm going to gut this guy. There we go. Wait a minute. Why isn't that coming up? Okay, let's try this one more time. Something did not go well here. Okay, so sealed. Why is that? Okay, now that's working. That's really weird. I was trying something a little different here using some vertical tabs. It's just going to help me with my notes on the side. Um, it looks like something wasn't quite working right with that. That's really, oh, now it's gone again. Okay, so that seems to be fail fast. Sealed has nothing in it now. Okay, now that's okay. That's really weird. Sometimes IDEA and Android Studio are a little bit weird. Anyway, the thing that was really nice about that is that the compiler, because of that contract, can now know that this condition is true. And that's why if I had something like this, it can come back here and say, hey, that's always false in this particular case. Um, so that's really neat. I really like that type of feature. There's you can write your own functions that do that type of thing. I haven't had a whole lot of luck writing my own functions like that. But if you have a condition where the passage of a certain function implies a certain value, this can be helpful for the giving the compiler a hint to be able to pick up things like that. Okay, so anyway, whoops. That's all I want to talk about fail fast functions. Any questions on any of that? Oh, oh, go ahead. It's not actually a constraint. It's basically something that's telling the compiler about what your function is implying. So in this particular case, we're telling the compiler that if somebody calls this function, that implies that that value is actually holding true or false. Um, and in this case, we're basically saying if it returns, meaning that it didn't throw an exception, then the value is true. If it doesn't return, the value is false. So that's really what it's saying. I think there are some contracts you can add in there that do some parameter checking, but I can't remember for sure. I really have to dig into contracts a little bit more. This is about the only thing I've really looked at for contracts. But it's really just telling the compiler if this function completes, here's what the state of my application is, state of my variables, so it can make some assumptions. Okay, let me get him. No problem. Let me get him out of there. There. Okay, so that's fail fast functions. Let's talk today about object-oriented programming. Woo, exciting. So there are three tenets of object-oriented programming. Name them. Anyone? Exactly. So there are the three there, and I'm just going to put them as actually I'll say encapsulation, inheritance, and polymorphism. I like talking about in that order. What's encapsulation? Hiding data. Now, I really like to look at it from a slightly different angle. Hiding data works. And from the original object-oriented programming concepts that were developed for the language called Simula, that was really the idea, is that every object is a black box and it has data inside of it that you really want to hide. If you look at a person, you don't see their heart, you don't see their lungs, you don't see their blood, unless you do something to them and the blood comes out. What you see is a black box or sack of gelatinous goo that represents this human. And to represent that in a simulation, which is where Simula came from, the idea was to try to make it so that the hidden parts are really hidden, and you can only ask the object to do things that you could ask in real life. Like you could say to somebody, "Hey, may I take your pulse?" And that's invasive. You're actually going to them and checking on what their pulse rate is. Um, in the real world, it's invasive in the you're touching somebody situation. You're not actually looking at the data on the inside, so you're really kind of asking them what their heart rate is at that point. So data hiding was really the goal back then, but I like to think of it more as a protecting data. For a lot of objects that you create, knowing that data is inside of it isn't really that big a deal. The less you know, obviously, the easier it is to modify the object over time, and you could actually modify the internal details without anybody on the outside being any the wiser, or breaking anybody. But a lot of times you're going to want to expose a lot of data anyway. Think of your typical person object that you're going to use in a program. You might be exposing the name and the age and some other information about this person, um, and keeping those internal and having to come up with some other way to get the name, like ask what is your name. It may be more realistic, but it's really just kind of a waste. It's really duplicative effort. So let me tell a little story. Back in the 90s, I went to London on a business trip. And on the weekend when I was up there, I did a little sightseeing. My wife at the time asked me to go to Harrods and get her something. So I went down to Harrods, and there was this huge wad of people kind of going into the store and, going in, doing the shopping, came out, huge wad of people going out the door. And it was, just people bumping all over each other. Uh, After all this extreme effort getting through these crowds, I was hungry. So I went to McDonald's. And the reason I went to McDonald's in the UK is because they have fried apple pies. And I don't know how many of you remember real fried apple pies at McDonald's. When I was a kid, that was the best thing ever. I mean, they were molten lava hot, and they were all crispy and bubbly on the outside, and they were amazing. And this past October, I was back in London again, and first thing I did was go to McDonald's and get a fried apple pie because they're the bomb. So I go to McDonald's. I ordered my fried apple pies, ordered Big Mac and Diet Coke, and reach for my wallet. My wallet wasn't there. At some point in one of those crowds, and I assume it had to be after I was in the store because I bought stuff, somebody picked my pocket and my wallet wasn't there. This was a real disappointment for me because I had my mouth watering for this wonderful fried apple pie and I couldn't buy the thing. That was my big concern at the moment. It wasn't, oh my God, somebody has all my ID and credit cards. Um, the big problem in this scenario is that I wouldn't have gone into McDonald's and had my mouth watering over this fried apple pie if I had known my wallet was gone. So really what I want to do is have some way of protecting that wallet, making sure that if somebody wants to get it from me, they have to ask me. And at the same time, I know that something's changing in my state. So when somebody comes up to me and says, "Pardon me, may I have your wallet?" I can say no. Or, I can say yes. But either way, I know my wallet is either still with me or I know my wallet's been given to somebody else. Now there might be a parameter on that request. Maybe there's a gun involved. And if they parameterize it with the gun, I'm going to probably more likely say, yes, here you go. But once again, I still know my state. By somebody coming up and pickpocketing me, I didn't know my state had changed. And that can create some huge problems because now your object has inconsistent state inside of it. Because that state change may have affected something else inside of your object that you're defining. So data protection is really, I think, the big key here. And whether or not you want to hide the data, that's the next step you could do. You could make it so that nobody even knows you have a wallet. Um, but in a case, there may be cases where, it's something that you need to expose in your program, the option for somebody to ask about your wallet, the option for somebody to get your wallet. So focus on protection as the big, big thing here. You want to make sure that people can't just modify your data. And to think about how that works in like a real life program, let's say that we had something like we were going to create a program that's keeping track of how much peanut butter there is in a jar. So let's say we had something like var amount of peanut butter, and I'll just do it in ounces. I really should do it in a different metric measurement, but we do ounces here, so I'll do ounces. So let's say we have the amount of peanut butter is 32 ounces, and then I'm going to create a function here to remove peanut butter and an amount, and I'm going to return the amount of peanut butter that was actually removed, and I'm going to say removed equals amount, and then amount of peanut butter minus equals removed, and then return removed. And seems like a simple enough little function here. It's telling us here that this is going to be unnecessary because I could have just returned amount, but we'll just keep it like this for the moment. This actually exposes part of the problem in not protecting your data. In this particular case, anybody can modify that amount of peanut butter, and it's up to the person doing that modification to make sure they're doing it right. And in this case, we have a problem here. So if somebody called remove peanut butter passing in 50, we're going to remove 50 ounces from the amount of peanut butter. And it's going to tell us we've removed 50 ounces. But we didn't have 50 ounces to remember. The amount of peanut butter is now going to end up set as negative 18 ounces. And that's really a problem for the universe because you don't want negative peanut butter floating around in the universe. Because if you put peanut butter on one slice of bread and negative peanut butter on the other and put it together, boom, annihilation. The universe is done. So you don't want to do that. We need to have checks. And of course, you could say, well, hey, it's they should have read the documentation. This person here needs to make sure that let's say max amount or whoops, actually min amount or amount of peanut butter. Come on. Something like that. And now we're in much better shape here. So what we're checking to we're checking to make sure that we have enough peanut butter to remove from this jar. We're only going to remove the minimum of the amount or however much there is if there's less. And now we're okay. But the problem is it's the caller's responsibility. And callers are infamous for making mistakes. So we have no control. I mean, somebody else could even write another function here that modifies that, and we have no control over it. Now, if we said private in front of this, in Kotlin, this now makes that amount of peanut butter only accessible inside this file. So at least we're not letting people in other files modify things, but anywhere in this file, there could be a mistake. And that's something we want to try to avoid. So instead, what we're going to end up doing is encapsulating that data inside of an object. And so we can define an object like this, PB jar. And inside my peanut butter jar, I'm going to put, whoops, that property that we're defining. And that's going to give me control. So now when somebody creates a peanut butter jar here, we don't allow anybody outside that peanut butter jar to modify this. And then we, of course, take this function and put the function in there as well. And now people can still make that same request, but now, because we've encapsulated it, whatever we write in our peanut butter jar, as long as we write code that keeps the state consistent, the outside world can't mess with us. So now this is completely hidden from the outside world. But hey, what did I say about before? I said we wanted to protect our data. I didn't necessarily want to hide our data. Maybe we want people to be able to see how much peanut butter is in here, but we don't want them to actually change it. If I made that non-private, the default in Kotlin is public for everything. So if I did this, this would be a problem, right? Because now anybody can modify the amount of peanut butter directly. I can create my peanut butter jar and say peanut butter jar dot amount of peanut butter equals 10. And that's out of my control. So what I really want to do is some finer grained control here. I want to allow people on the outside to get this value, but I don't want to allow them to set it. So I'm going to modify my setter by saying private set. And what this does is this changes the access of the setter and only the setter. Because the var itself is public, the get is still public. But because I said private set, I've now restricted it so that only the peanut butter jar itself can modify it. But from the outside, anybody can ask to get it. So if I came in here and said I have a main, and I'm going to say val jar equals pb jar, paren, that creates it. And then I can use it. I can say jar dot amount of peanut butter. I can print that just fine. I can remove some peanut butter from it and say I want to remove 10 ounces of peanut butter from that. And let's do that a few times there. And let's just kind of see how this happens. If this works correctly, I should get down to 0 amount of peanut butter at some point here. And then the last remove should only say it removed 2 ounces. Let's just actually see what happens when I run this. There we go. So we'll see here that, what is that last one? Well, that is interesting. You're right. You are actually right. absolutely right, because I am calling that separate function. Thank you. That was silly. I thought I was going insane for a second there, but you're absolutely right. Let's do this properly. Let's talk to the object and not just that rando function up there. There, that's what I wanted to have. So we'll see here that we start off with 32 ounces. We remove 10. We're now down to 22. We remove 10. We're down to 12. Remove 10. We're now down to 2. We remove only that 2. The request was removing 10, but I only get 2 back. And then we zero out. So that did it. Thank you for catching that. And I appreciate that, by the way. It's like, every once in a while I'll be in the middle of something here and I'll make a mistake and not notice it. Please, please, please point them out for me. Um, so this now exercises control, and that's great for encapsulation. Or encapsulation is great for control. Oh boy, I'm having one of those finger days. There we go. Okay, so any questions on that? That's the first big tenet of object-oriented programming, and as far as OO is concerned, I think that is hands down the most important thing that object-oriented programming brought to us is giving us control of our data. That's huge. The other things are, they can be helpful, but they can also be confusing. And in a lot of cases, you're really not going to use them as much as you might think. So let's talk about some other stuff here. Inheritance. What is inheritance? Any ideas? Hard to describe without the word inherit, isn't it? Creating more specific objects based on existing objects. We'll say that. Let me say classes instead of objects there, because that'll get confusing later. So if we have an existing class and we want to make something more specific, and I'll say possibly adding properties, functions. So that's a pretty good way to describe it. You're basically saying, I have something and I want to tweak it. I want to change it slightly. I want to add some stuff to it. Um, one of the things that's, of course, key to this is Liskov substitution. Substitutability. Did I do that? Ooh, I think I did that one right. So Liskov substitutability basically says anywhere you could use the existing class, you can now use that subclass as well. And that's hugely important. Um, it's one of those concepts that, once you get it, it's super simple. It makes a lot of sense. Kind of like, when I heard about the pigeonhole principle in math, it was kind of one of those, well, duh. I mean, if you have 10 holes and 11 pigeons, one of the holes is going to have more than one pigeons. Um, but it's kind of like it's a super useful way to describe something, even though it's a simple concept. Saying pigeonhole principle is a lot simpler than explaining what the pigeonhole principle is. And just as a by the way, that type of concept is really where design patterns come in quite a bit. I look at design patterns as a language thing. It's really giving you a way to express your intent about what you're doing with something by using the term, like let's say abstract method or template method or um, decorator. When you use those terms, you don't have to explain what you're doing. If people know the terms and know what they mean, communication's simpler. And that's basically what the pigeonhole principle is all about. It's just a simpler way of communicating a concept. Liskov substitutability is very, very similar there, where it's a simple concept, but it's, describing it, it's much easier to say, oh, Liskov substitutability. So let's talk about that a little bit. Let's first of all talk about real basic inheritance to start with. What if I defined a class called mammal? Let's see, we have kingdom, phylum, class, order, family. Do I remember them? genus, and species. I think that's right. Does that sound right there? I probably am spelling phylum wrong, but maybe it's PHY. It's probably PHY, and then probably an E. I'll have to look it up at some point. I have, that looks like phlegm. Um, I'm going to do that. I'm just going to leave it like that. I'll look it up later just to make sure, but this is about all I remember from biology class, so I always like to write it down: kingdom, phylum, class, order, family, genus, species. And at each level here, we're getting more and more specific on what something is. And if we came down to, I think mammal was a genus, but I'm not sure. But let's just suppose it is for now. I'm not a biologist. If anybody's a biologist, please feel free to correct me at any point here. Um, but let's say that we want to describe something. Categorization is super, super useful to us. It helps us be able to reason about things, not only at the very specific what this thing is level, like a cat or a dog, but at a higher level so that we can group things. Our mind loves to group things together. So if we think about a mammal, there's certain traits to a mammal. Things like it typically has hair, it typically gives live birth. I'm going to say typically there because yeah, there's some weirdos in there. You have your echidna and your platypus, which lay eggs. Um, it's weird that way. There's some exceptions here, but in general, when you think of mammal, you think of a fuzzy, warm-blooded thing. Uh, so we have our mammal, but then we're also going to have cats and dogs, things like that. Now you'll notice here in Kotlin, I can say class mammal, class cat, class dog without adding any more detail. I can just say this is a concept. But now I want to relate these concepts to each other. So what I want to do is say cat is a mammal and dog is a mammal. And then maybe at a much higher level, maybe if we go to the kingdom level, we have animals, and mammals are animals. And so we can kind of relate all of these together. Maybe we don't need all these intermediate parts here. We're just going to have animal, mammal, cat, and dog. Each of these has certain relationships, and we can make assumptions about them. So things like, animals versus plants, you're not going to have a mammal that does photosynthesis. So, at least I don't know of any. Maybe at some point we do. Maybe there's one of those ones that's like underwater because, underwater there's lots of weird animals and things. Um, but let's relate these guys. Let's say that a mammal is an animal and cats and dogs are mammals. We can do that by saying colon and then the superclass and then have a superclass constructor call on it. And we can do the same kind of thing down here with mammals and dogs. Now, of course, we're going to see that there's some errors here. And this is where I think there was a severe design flaw in Kotlin. And there's two things that happen by default. One, everything's public. And I think that's actually a good thing. So, when we have defining a class animal, it's public by default. Anybody can use it. Anybody can get to any public features of that animal. But there's another problem. Everything is final by default. I'm going to say final/closed. And what that means is that if you try to extend it, if you try to add features, if you try to tweak behaviors, you can't unless you explicitly open it. So we have to, in this case, say open animal and open mammal. And there's some concepts out there saying that you should be able to read things, but you shouldn't be able to modify them by default. And this really, I'm not a fan of that. On my side of it, I like to look at things and say you should be able to modify things by default. If you want to extend something, where's the harm? Unless you have a specific reason not to. And typically that reason is a security thing. So if you're writing some kind of a program that was a communications protocol and you wanted to secure it, you probably want to make that communications protocol non-open so that nobody can modify it and sneak in some behaviors that somebody else might accidentally use. Again, it's about control there. But in a lot of things, like if we're talking about defining mammals and animals and cats and dogs, it probably doesn't matter. It's probably okay to say, hey, I've got a library with animals and mammals. somebody else can extend them in their own library they've created. And if you didn't happen to make them open in your library, nobody else will be able to modify them. There's a couple little things we'll get into later with extension functions, which are basically syntactic sugar that make it look like you're modifying it, but you're not really. But for the most part, you can't modify those. So personally, I think that's a design flaw. Um, but what we've defined now is mammal is going to inherit everything that animal can do. So from a Liskov substitutability point of view, you can use a mammal anywhere you could use an animal because it's going to be able to do the same things that an animal did, and it's going to you can request, it has the same properties, and you can ask it to do whatever an animal can do. Um, that ends up, I'm going to call this main one over here. That allows us to do something like val animal equals, well, I'm just going to say cat in this case. So we'll notice here that from a compile point of view, the type of animal is animal. The only things we know about that variable based on the compile time type of animal are things that animals can do and things that animals are. As long as a cat is an animal, which in this case indirectly it is, a cat's a mammal's an animal, we can use a cat anywhere we can use an animal. But we still don't know that that animal is a cat unless we go and ask it, what are you? And then it returns, I'm Batman. So let's put some behaviors in here and some properties. We can do that by putting open curly braces and then define properties inside of there. I'm going to say that all animals have a name, kind of like that. And we're going to define it as all animals are named Batman as long as I'm on that tear there. So by default, everybody is Batman unless you tell them otherwise. Whenever I create a cat, he's going to inherit that name, and the cat's name is going to be Batman. So if I come down here, I can say println animal.name. Boom. And now if I run this, of course, I should see Batman. Good. Okay, so I see Batman. So I now have this cat that does everything that an animal does. Now, what if I did this? And then printed the cat name. I should see the same thing, right? Uh, because a cat inherits all the capabilities of the animal. Up here, when we make this animal call, we're taking a look at the type of animal, and we know that that type has a name, so we can call name. Here, we're looking at the type of this cat, which is cat, and directly, he doesn't have a name. Indirectly, he does, because a cat's a mammal's an animal, and an animal has a name. So we inherit that capability from him, that property. And of course, we could have a little function here, maybe a little running function. And so we could ask the animal to run, and that's perfectly fine. We can ask the cat to run as well, and we should see them running. So we'll see Batman and running a couple times there, like that. So that actually behaves very nicely. And what Liskov substitutability meant for us is that for this animal, we can plug in any cat, and when we ask him questions, when we ask him to run, he will be able to do those things. Now, note that I said he will be able to do those things. The actual functionality might not be the same, but we know that every animal has a name and has a run function on it. Um, that gives us the capability of plugging in different types. So if we had a function, go animal, taking an animal that's an animal. In this particular case, all we know in this function is that it's an animal. We don't know that it's possibly a cat or possibly a dog, whatever. All we know is it's an animal. But when we call go animal, we can pass in a dog or we can pass in a cat, and everything's fine there. Those will work just fine. we can pass in a mammal, and that'll work just fine. But let's think about that last part for a minute there. Does it really make sense to create a mammal? Is there such an instance? Can I say, oh, hey, let me create a mammal? I mean, I can create a cat, I can create a dog. Those are actual concrete things. Mammal is an abstraction. It's just a concept, a grouping of types of animals. And by itself, saying create a mammal doesn't make any sense whatsoever. So what we can do is we can put a keyword on here. I think that's just because it's redundant. So it says, oh, it's just the order it doesn't like. But I think it's still gonna, oh, notice how it got rid of the word open when I did that? If I said abstract open, that's actually redundant because when something's abstract, it has to be open. But if I change that to abstract, anyone know what abstract means when you're talking about an object-oriented programming language? Exactly. And that's the exact definition I was looking for here. All abstract means at a class level is you cannot create it. That's the only thing it means. You can be forced to be abstract. Like if you have abstract properties or abstract functions, then because you're missing pieces, you don't have a function defined or you don't have a property defined, you have to be abstract. But at the top level, all abstract means is you can't create it. And usually you would put that at the top if you're forced to, or if it's just a concept. It's an abstract concept there. So in this particular case, notice what happened down here now. When I put abstract on that, I cannot call mammal by itself. It just doesn't make any sense. And I'd probably want to do the same thing up here for animal, something like that. Because again, he's a concept. I'm just going to leave animal open. I'm going to put here should be abstract. Open makes it extendable. Abstract makes it extendable as well and kind of forces it to be extendable. But that's, again, all that abstract means is you cannot create it. If there's anything inside of it that's abstract, it forces that. One of the misconceptions about, when Java was around is people would write things like an abstract class has abstract methods. And that's not necessarily true. Everything inside of it could be completely concrete, and maybe you just don't want people to create instances of it. So we can't create it. That's abstract. So I'm going to comment that little sucker out there. Any questions on any of that? Okay, so far we've talked about inheritance. Let's look a little bit more at, maybe some things that we might have inside here. We've inherited name, we've inherited run. What if we want to change some behavior? So let's say that we have a create child. I'm going to say birth child. How about that? And no, that's actually not how I want to do it because that'll vary in the return type. Let's do a fun blood temp range, something like that. And maybe the blood temp range here is, let's say an int range. Maybe we're going to return, oh God, I have no idea. I'm going to say 50 to, well, let's say 80 to 110. I don't know, something like that. So maybe by default, we say that animals have a blood temp range. Oh, actually, it might be, let's just say 0 to 110. Why not? And then a mammal might want to change that behavior a little bit. We could just inherit it and get this range by default. And again, I'm not a biologist, so I'm sure this range is way out there. But for a mammal, we might want to be more specific on that range. And instead return, I'm just going to say 80 to 110. changing that behavior slightly so that if we ask a mammal what its blood temperature is, we'll get a more specific range than up here. And this is perfectly fine. Note that it's the same question being asked, blood temp range. So from a Liskov substitutability point of view, we're asking it to do the same things. So a mammal can be asked the exact same question as an animal. But we can give a different result. That's perfectly fine. Now, what's the error here? This is something that in Java was done super, super poorly. In Java, we had a little annotation called @override you could put on things. And what that did is if you explicitly put an @override, let's say that, and I'm going to kind of fake this up for a second here, because that's a Java annotation. And if I said @override fun blood temp range, I did something kind of like that. And we can return. Let's say that I did something like that in Java. Um, what that override is doing is if you use it consistently, this is telling the compiler explicitly, I meant to override the superclass function. So I meant to replace it. But notice I made a typo here. I spelled it wrong. What this would do is the Java compiler would say, there is no blood type temp range in the superclass. So maybe you made a typo. And that's one of the advantages that override would do for you. The other was the compile. If you didn't have it in there, you could actually tell the compiler to warn you about it. So if we use the same name, like in this case, blood temp range, we might be accidentally overriding it. And so if you didn't have that annotation, the compiler could say, did you really mean to do that? You're changing behavior here. Maybe you accidentally reused the same name. Now in Kotlin, they decided to go a little bit firmer on this. Instead of using an annotation on that, which is just kind of extra data attached to a function, they made a keyword in the language. So if I float over this, this is going to tell you, hey, he's hiding a member of the supertype. What that means is I'm replacing something from that I'm inheriting. So in this case, I'm replacing that function. And what it says here is if you really meant to do that, you have to tell me explicitly. So in this case, I have to put in override. And now we're seeing part of the problem with the whole everything is final. Because blood temp range here is not marked open, I can't override it. And this is one of the places where I think it's even worse. I mean, it's bad enough at the class level, but at the function level, when you want to override it, you have to explicitly make the superclass open. And what this means is if you had a class defined in somebody else's library that you can't modify, you're stuck. You can't change that behavior that way. And this is something that can be really problematic. So I really wish that open was the default on this. But hey, when you have a language that has so many great features, I can deal with this one. Unfortunately, that when it's come up for me that I've needed to, usually what I've had to do is make a complete copy of that superclass and then tweak the superclass. And that's horrible for maintenance because then if somebody changes their library definition of something, I have to change my fork of it. But then the open lets you override this. Now, if you had said override and then mistyped it, you're going to get that same kind of an error here saying you're not really overriding anything. So maybe you made a typo. Maybe you changed the signature. Maybe you changed the parameters to the function. So this override one is great to have as a kind of forced feature in the language. In Java, there was some optionality to it. You could optionally put the annotation on, and you had to tell the compiler that you wanted to check for it. So I'm going to say I want to explicitly override this. Now, this type of behavior, when you're overriding that functionality and having it be a little different based on the subclass, this is known as polymorphism. And I probably should have asked you guys, what is polymorphism? This is polymorphism. And it's all about overriding things. The thing that is interesting about this is polymorphism can have some really tricky effects. I'm going to go into a lot of detail on this in a little bit. That's what all those scenario packages are for. I don't know if I'm going to use all of them, but I want to go through several scenarios, just kind of walk through how does polymorphism work in Java and Kotlin, because the behavior is the same for both languages, and it's not necessarily what you might expect. Um, there's some cases in it where I really wish they'd done it a little bit differently, but we'll talk about that in a little bit. So basically, we're overriding things. What's the difference between override and overload? Anyone? Exactly. And the As far as overloading is concerned, when we're talking generally when we talk signature, we're talking the name, the parameters, and the return type. That's the type of thing that makes up the signature. But for overloading, it's only the name and parameters part of the signature. Um, if you end up changing the return type, then it's providing variance on it. So what you're doing is you can expand. Let's expand or reduce. Yeah, you can expand the type that you're returning from something. Like for blood temp range, I could change it to just range instead of int range. I think int range extends range. Let me just double check. No, it doesn't. So although it might be, is there an interface for range? I can never remember about that. Well, closed range. So it extends closed range. So I could change the subtype to be closed range. I'm sorry, it's the other way around. I can make it more specific on the return type because in order to adhere to the superclass, I have to be able to be what that super type was. I can't, for example, if I said I'm returning a mammal, I can't say that I'm returning an animal in a subtype, but I can say I'm returning a cat, so I can get more specific on it. Let me get rid of him for a minute. So overload have different signatures um, with same name. Put that in there. So it's just the parameters really that make the difference there. Override, same name. I'm just going to say same signature in general. Whoops, same name and parameters. That's the big difference there. So for override, what you're really doing is changing behavior. And for overloading, you're reducing the namespace. And I'm going to also say surface area of the type. And this is actually something that object-oriented programming was great for. If you think about before objects and somebody's writing a bunch of functions, if you want to write functions to, let's say, add two integers or add two floats or add two decimals, well, decimals are floats, or let's say add something to a collection, you had to give them all different names. All the functions had to have different names. But with overloading, we can actually use the same name, and that makes it easier to grok the library that you're dealing with. If the library uses the word add for all those, it's much easier for you to make an assumption while you're programming what's a valid name to use. You're not going to have to go to the documents quite as often. If you think about different types of collections, maybe you're adding something to a binary tree, or adding something to a list, or adding something to a map. Although maps you usually use some different syntax. Um, you might have had to say add to tree, add to map, add to list, uh, add to set, and it's awkward. You have to actually look up all those different names. By reusing the same names, as long as the functionality is consistent, you're making it simpler for somebody to actually understand your library and make assumptions about what they can do with your library. Okay, so any questions on those concepts? Now, obviously, I'm assuming that everybody here has a base familiarity, at least, with object-oriented programming. I'm just, trying to do a little bit of review here. If this were an object-oriented programming class, I'd be going through this a lot slower and a lot more detailed for these things. But we're going to hit certain details along the way. Okay, so that is the real basic object-oriented programming stuff. Let's take a little closer look at that polymorphism and see exactly how it works. I'm going to go to my scenario 01, and I'll just call it scenario as the class, the file name there. Throw a main in there. And what I want to do is I'm going to create a little example here where we're going to work with a toolbox and put some tools into a toolbox. And then I got to come back to this other stuff here. I'm jumping around a little bit on where I wanted to go with things, but I think this actually makes sense at this point here. So what I want to do is, first of all, define the concept of a tool. So I'm going to make that a class here. It's kind of simple like that. I'm making it open so I can create extensions on it. And then let's create a couple different types of tools. Let's have a screwdriver. He's a tool. And a saw. He's a tool. So we have a couple types of tools. That's great. And let's create ourselves a toolbox to put these tools into. And inside of here, I'm going to have a tools property, which is going to be an empty list of tools. Now don't worry too much about this part here. This is a generic specification. Empty list will let you create a list of any type of thing you want. It just needs to know the type that you're giving it so that the compiler can work with it later on. So this is going to create a list of tools. This list of tools is going to be non-modifiable. He's not going to have any type of mutator functions. So you can't add to it, you can't remove from it, you can't set specific parts of it. What that means is that anytime I want to change the list, I have to create a brand new list, adding in new items to it, and then assign tools to that new list. Now looking at this, I have an encapsulation problem. Anybody on the outside can change that. So this is another one of those places where I'm going to want to say, add a private setter here. From the outside, people can ask what tools are inside there, but I don't want them to modify that tools. What I do want to do is have control of that. So I'm going to define an add function here, taking a tool, and maybe I'll just put a little println here. Let's just say this. Let's say toolbox.add tool. It's going to make a little note there. And then I'm going to say tools equals tools plus tool. So what this part here does, it creates a brand new list that had whatever was currently in the old list, adding the new tool in. Now, a little note on that, lists are not deeply copied. They're all shallow copies when you do this. So what I'm really creating is a pointer to this tool, taking the pointers that were in the previous list and then putting all those pointers into a list. So I'm not duplicating all the actual tools themselves. I'm duplicating the pointers to the tools. So this is going to create my new list there. Boom. So I have a simple toolbox here. He's complaining up here because I'm not currently using tools. So he's saying that this could potentially be private. Let's see how we can do this. Let's do something like a val toolbox equals toolbox. And surprisingly enough, the type of toolbox is toolbox. So if I wanted to, I could be explicit here. But you'll see that it's grayed out because I don't need to specify that. Kotlin's inferring that, and that's perfectly fine. But let's say that I want to add some stuff to the toolbox. So if I said val saw equals saw and val screwdriver equals screwdriver, then I can say toolbox add saw and add screwdriver. Pardon me. And let's put a little couple notes in here. So we'll say println adding saw, adding screwdriver. That word was remarkably difficult to type for some reason. I don't really type, by the way. I just kind of, my fingers randomly go over the place. I really wish I'd taken that typing class in high school. Um, so doing this type of thing, if I come down here and I say println toolbox.tools, let's see what this actually comes up with. I'm going to go ahead and run it. So we said adding saw, we had that call, adding screwdriver, we had that call. And so now it's telling me that I have a list, that's what these brackets are printing out here, of some objects. These objects that I defined, you'll see that it says this guy's a saw and this guy's a screwdriver. I didn't define any way for them to announce themselves to the world, so no way to print them out nicely. So by default, what it does is it creates a hash of basically kind of like the address of where this thing is in memory. And this one can be fairly useful, but it can be much more useful to define explicitly what you want to print out when you're debugging. And I want to make a real clear note here. This calls toString on each tool. ToString is intended for debugging, not to be user-facing. And that's a point I like to make with Java and with Kotlin. Don't use toString as the user representation of something, because that would give you would give you one true way to display the data. ToString is super, super useful for debugging, and nearly every ToString you're going to see in the wild was written from a debugging point of view. And so it doesn't look like something you want to display to the user. So if you want to display something to the user, have some code somewhere else that grabs the pieces of data from that object you need and formats it whatever way you want. That gives you multiple ways to format and display the data for the user. So let's actually, while we're thinking here, let's make it a little bit cleaner to display some stuff here. And so what I'm going to do is, oops, why is that not working? Let me right click, Alt Insert. I thought that's what I was hitting. That is not, that's interesting. Maybe it's because I have my insert key, I probably have my insert key on the keyboard disabled. That's what it is. So I'm going to go down to generate, and I'm going to say toString. And what this is going to do is ask me, first of all, which properties do you want to include in here? And there's nothing to include, so I'm just going to say OK here. And notice that this is just saying I'm defining toString, and I'm just going to print out the name tool for that guy. Now that's not super useful because we don't know what kind of tool it is. So maybe I want to ask what kind of tool you are, or I can override it. So one simple way to do this would be to generate a toString, and he's going to print screwdriver. And I can do the same kind of thing down here. Generate toString, and he's going to print out saw. So here I'm using polymorphism on this toString function. Notice that it's override because the superclass of tool, which I'm going to talk about in a little bit, has a toString defined. His default toString does that hash thing that I was talking about. I'm overriding its behavior to print out tool, screwdriver, and saw. So now if I run this guy, I'll actually see that there's a saw in there and there's a screwdriver in there. Now, why are there parens after these guys? If I had properties in here, the properties would appear inside there. So if I came up here and let's say that I had a var name as a string, and I'll take a break in a second here. When I generate this, it's going to give me an option of which properties I want to include. And I'll hit OK, and boom. So now we see it's tool name equals quote name quote. I can do the same kind of thing down here. Let's just do it for screwdriver. And hit OK. Whoops. There's a superclass option or something like that. Let's see how that looks. Oh boy, I don't like that. That's kind of gross. I'll just leave it as that for the moment. When I run this, we'll end up seeing, now that we see screwdriver, the superclass tool name actually is printed out inside there as well. So typically what you'll see when somebody creates a toString is something that looks kind of like this, where you'll have the type and then either parentheses or brackets or curly braces or something, and then a list of properties spelled out there. So this is not something that you'd want the user to see. It's not user friendly, but it's useful to you so you can actually see, oh, here's tools with different names, things like that. And now I'm thinking of Brave Little Toaster. That was a great movie. If you haven't seen Brave Little Toaster, watch that. It's really cute. Um, and you have Tony the Tiger as a vacuum. So this is something that, typically what I would do in Java for this is I would dynamically grab the name of the class and then have a separate function that generates this list of parameters. I'm not going to go through the details on that. It's a little tedious, but it's a good way to do it so that you only have to define two string in one place. So if I wanted to define that two-string in one place, really what I need to do is have the class name obtained there. So I could do something kind of like this dot class, or this colon colon class dot simple name, something kind of like that. And get rid of those. What is he unhappy about? Oh, it's nullable. Ah, I'm going to cheat for a second. Please ignore what I'm typing. We'll talk about that later when we talk about nullability. Why is that nullable? That's interesting. Um, yeah, but let me wave my hand at that. Ignore that for now. And this is something you really almost never want to do. But this is it's a good get out of jail free card for a quick example like this. So now I can kind of go back to what I had. And now when I run it, it's going to actually print out the types of them, which is really going to be pretty useful for me here. Let's see, almost never use bang bang. I just want to make sure I put that there. We'll talk about this later with nullability. Just unfortunate. Why would the name of the class be nullable? That might actually just be a JVM versus other platform issue, because if you're writing Kotlin code to run on non-JVM platforms, so if you're running it not on the Java platform, um, it might not be able to get that information. That might be why it's nullable. But yeah, that caught me off guard. That's interesting. So anyway, we're seeing now that we're printing out this list of what's in the toolbox. We added stuff in the toolbox, and so far that all seems pretty reasonable. After the break, we're going to take a little closer look at what happens when we start creating subclasses of the toolbox. So let's take 10 minutes. We'll start back up at 8:46. There we go. Okay, any questions before we move on? hmm hmm Yeah, so what I was doing, anytime you override, you're overriding whatever your parent had. So if your parent may have directly defined something, or your parent may have inherited something. In this particular case, tool is inheriting toString from a type called any. In Kotlin, any is the equivalent of object in Java. Um, so in that particular case, tool, if you don't specify a superclass, you're explicitly overriding any as your superclass. So any define that toString, we're overriding it here. When screwdriver overrode it, he's overriding the one that tool defined, whether tool did it directly or not. So if I didn't have toString inside tool, then the override in screwdriver would have been overriding the one from any. But always think about it as just I'm overriding what my parent has, either directly or indirectly. Okie dokie. So let me make a copy of this guy in another package. There we go. So this is scenario 2 that we're going to do here. And let's see, what did I want to tweak here? What would happen if I tweak these guys? Right now, the type of saw and the type of screwdriver is saw and screwdriver because I'm inferring that from the actual type. If instead I had done this, note that the type of saw and screwdriver is tool. So I should have the same behavior, right? Because there's only one add function that I'm calling here, and that's the add taking tool. So whether it's a saw, whether it's a screwdriver, that all makes perfect sense, right? So that's fairly simple. But let's get a little more interesting here. Let's say that in Toolbox, I come up here and I add an explicit, oops, let's make sure we get this guy, an explicit screwdriver function here. And I'm going to say here something kind of like that. So what I've done between these two, these are overrides, or sorry, these are overloads because I'm using the same name but different signatures. But now let's see what happens in my subclass down here. So if I run what I have right now, let's put an A there and a B there. And let's say we add the saw, which function is called. So I'm going to go ahead and launch this little poll here. So if I write my code like this, on line 31 there, which function is being called? And go ahead and answer in the poll here. This is all anonymous, by the way. We have one call for A. Any other guesses here or statements here? It's okay to guess. That's fine. Not a problem. So we have 2 for A, 3 for A. Okay, I'm just going to go ahead and say that's cool. So we have now 4 people for A. So it looks like everybody here is pretty comfortable that A is what's getting called, right? In this case, that's kind of obvious, right? Because saw doesn't have anything specific to it. It has to be calling. This is the only possible signature that will resolve there. Now, what if we did the same question, whoops, on line 33? I'm going to go ahead and relaunch that poll again. What do you think is going to get called either A or B on line 33? We see a B, we see an A. So I've got 4 answers so far. Anyone else want to take a guess? I'd love to get all 6 on this if I could. Okay, well, I will end it there. Let me show you what the results are on that. So notice that one person said A, 3 people said B. Let's think about this for a second. Let's see. These I did have them print the functions there. Let's run this and just see what it does. Notice that it actually called add tool. Now, why is that? Why did that happen? It's a compile time versus runtime issue. Think about the type of screwdriver at compile time. So the compile time type of screwdriver is tool. So what that means is that the compiler is going to look at toolbox and say, okay, what is toolbox? What's his compile time type? It's toolbox. What's the compile time type of the argument? Tool. Because of that, I'm going to look at the toolbox class to see if I have an add taking a tool. And so it's going to find this signature. And it's going to remember that signature. And this will get a little bit more interesting when we have a subclass, because then you have a runtime aspect to it as well. But the signature at runtime is the first really important key here. So the runtime signature is going to be toolbox.add tool. That's what it's going to be looking for. Now, if instead, let's go ahead and create a second screwdriver. And let's say that that second screwdriver, instead of saying tool there, if I said screwdriver, whoops, kind of like that. Put this guy up here. I'm sorry, not the runtime signature, compile time signature. Let's put the right words here. So in this particular case, it looks at it and it says, okay, I want to add a screwdriver to it. So it's going to see screwdriver as an option here for this guy, right? So now let's do one other one here. I say saw 2 with a type of saw. And I say adding saw 2. Let's go ahead and just ask the question here, what's going to get called? So if let's see, stop sharing that. I'm going to relaunch the poll. Go ahead and which function do you think is going to be called here? Anyone else? Okay, I'm getting consistent. Everybody's saying A, which is great. Uh, and this one, it's fairly obvious, right? When I say add saw, the compile time signature, it goes up there and says, what's going to be the best fit for add saw? And the only possible option here is add tool. And saw 2, his type was saw, but I don't have a function that can accept that. So the compile time signature is going to be add tool. Okay, any questions on that? Okay, so let's see, what was my next one here? Let's say that I'll take that guy, copy him, and I'll paste him into here. Let's take a look at this guy. What if instead of doing it the way that I'm doing it, what if I said val tools equals list of saw and screwdriver? And then what I'm going to do is say adding tools. And let's say for tool in tools, toolbox.add tool. And I'm going to go ahead and put the little poll back up here again. What's going to be called on that line? Any idea? And this one's going to require a little more intuition because there's a couple things here I haven't told you explicitly about yet. But people are saying A, and I'm happy with that. This one feels a little intuitive, right? Let's kind of walk through what's going on with this. We want to find out what type tool is here. So to do that, we have to say, well, tool is being taken from this list of tools. List of is a function that we haven't talked really about. It just creates a list of things. What type of items are going to be stored inside that tools list? Well, let's take a look at what we got. We have a saw and we have a screwdriver. What's the common superclass between those two? It's tool, right? So the only thing that list of can do when it's creating this list is take the closest parent type, the closest common parent type between these two guys. So he says, okay, this is going to be a list of tools. Now I can explicitly say tool there, but notice how it's grayed out because it can infer that for us automatically as the common supertype for these guys. So if I end up floating over tools here, it's going to tell us this is a list of tool. So we know that each tool in there is going to be of type tool at compile time. The only possible option is for every single call here to call list tool. And this ends up surprising people a lot because they might think that at runtime it's going to figure out which one to call and say, oh, hey, one of them is a screwdriver. It should be calling add screwdriver. But that's not the case. It has to resolve the signature at compile time. So compile time signature is add tool. Um, Now at runtime, it's going to take a look and say, well, what is toolbox? Well, toolbox is a toolbox. Let me call the add tool function inside toolbox. Okay, question so far? Yes, it does. Mhm. Yep, it behaves exactly the same way. The syntax is a little bit different, but it's basically the exact same thing. And the behavior with the compile time signature resolution and then the runtime resolution is exactly the same. And it ends up being a little surprising because when people think of polymorphism, they tend to think, oh, it's all dynamic. But it's not. The compile time resolution can really get you. And in a moment here, we're going to get to a point where polymorphism steps in, and then it gets even more interesting. Okay, so there's that guy. Let's make a copy of him into there. And let's tweak things a little bit more. If we want to explicitly say for each type of tool, go ahead and call the appropriate function if it exists. We have to be a little more creative here. We need to make the compiler understand what something actually is. And one way we can do that here is to take advantage of our when and say when tool, and then inside here saying is saw, and this is where it's going to get really interesting looking, is screwdriver, else I'm going to go ahead and do that. Now that looks kind of messed up, right? I've got 3 calls that look exactly the same. But what's going to happen on this? Let's take a look first of all here. We're saying, okay, this thing's a saw. We're going to call toolbox add tool. Well, what do we know about tool? What is the compile time type of tool? Any ideas? So at the point in the statement it's a saw. Why would you say it's a saw there? So we're checking whether it's a saw or not, and that actually relies on knowing something about Kotlin. Because you are actually correct. At that point, if I float over tool, whoops, why did that one not, that's interesting. I think there's a bug in the linting here, or the highlighting. We should see something kind of like this. Smart cast to blah, blah, blah screwdriver for null call. Now, Kotlin does this thing called smart casting. If when it's looking at the data flow, it can make an assumption about what some type is, it'll use that type. So in this particular case, tool has been changed at this point in the code because Kotlin says, hey, I know on this side that it has to be a screwdriver. Therefore, I can treat it like a screwdriver. And so it converts this to a screwdriver. And now when I call toolbox.add, it'll call toolbox add screwdriver. So if we run this, Boom, we see toolbox add screwdriver being called. Even though the calls are exactly the same on all these lines, the compiler is treating them differently. Smart casting is really cool. And this first one here, I don't know why it's not saying that that's, it might be because it doesn't need to, because, you know, let's see, if I add in another one up here for saw, I bet it'll highlight him and mention the smart cast. Yeah, so he did highlight it. So that's interesting. The data flow that he's doing there is basically saying if he doesn't need to smart cast it, he won't. That's really interesting. I didn't know it would do that. I thought it would always smart cast. But the idea behind a smart cast is that if you have some kind of condition, it can check things. And this also works for if tool is screwdriver. Stop assuming I want that one. Then we can say toolbox dot add tool. And notice how that little green highlight's applying there. It's smart casting at that point as well. Now this will only work if it knows for sure tool couldn't change between these two lines. So in this particular case, when I say for tool in tools, tool cannot change. Nothing else in our code can change it. If, however, I did something like this, um, if I do this, he's probably going to be okay. I'm just going to double check this. Whoops. Tool equals tools. This one probably won't work, but we'll give it a shot. It's probably going to say everything's fine here. Yeah, so he's able to smart cast that. The reason he's able to smart cast that is even though this is a variable, at this point, nobody else could possibly modify it between this if check and where he's actually being used. If instead I did something like this, now you'll notice here that there's no reference to the smart cast. If I float over this, all he knows is the type is tool. And what's going on here, and we're going to see this later, it's going to be much more obvious with nullability. Between the time we check this and the time we use it, it's possible that somebody else, you know, some other concurrently running function could have changed tool. And so he can't make the assumption that it's a screwdriver at this point. Here, however, because tool cannot change, nobody else can tweak it. We know that if we test it, at this point, it's definitely going to be a tool. Now this can, you know, make it a little bit more confusing in your code because you'll notice here, because this is a tool, we're going to call add tool for this guy versus this one, we're going to call add screwdriver. So this is something to be very careful about. And this is one of the reasons why I really prefer making things vals when possible. Now, obviously this isn't going to work down here because, oh, well, yeah, it does work. Wait a second. That's not what I wanted to do. I wanted to make this a screwdriver, didn't I? Yeah. Yeah. So here we're still going to see the way this is it can't do the smart cast because it's a var. Somebody else could have changed it. But if I made this a val, now down here, notice the smart cast actually takes place because he knows that nobody else can change it between when it was checked and when it's actually used. So using vals as much as you possibly can sets it up so smart casts can apply, and it can really reduce some of your code as well as make it more consistent. You'll notice when I had it be a val, it ended up having a very different result here just because it couldn't do the smart cast. Questions on that so far? We're going to talk more about smart casting later, but any questions at this point? So we're taking advantage of the smart cast in this tool, in this when expression here, to actually trigger the appropriate one here. But yeah, that's, you know, having to do this for every single piece just to get the compiler to cooperate with you is kind of painful. This is one of the reasons why you'll often see instead of people using overriding, they'll have a single function that has a when inside it and then actually checks the types of everything. It's a little bit more reliable, a little bit easier to deal with, but you end up having the extra hit of a runtime check on that. Okay, questions? Okay, so let's start doing some polymorphism on this. So in this guy, let's create something I'm going to call a smart toolbox or a safe toolbox. First of all, I'm going to make the class toolbox open so I can extend it. Then I'm going to create a safe toolbox, which extends toolbox. And the whole point of the safe toolbox is if I have something that is potentially going to cut my hand, this toolbox is really nice and automatically wraps it so that when I reach in the toolbox, I won't cut my hand on a saw, for example. So inside here, what I want to do is I want to tweak the add saw. I'm going to go ahead and put this in here. And I want to make this be saw. And we're going to say safe toolbox add saw. Adding safely. And then here, I don't have direct access to that tools property there. So what I can do is I can either make this protected, which is a different data setting, and then use the same thing like this. But I don't like this so much. Making values settable in subclasses, because somebody else is defining the subclass potentially, they may be working with it differently. We're kind of bending encapsulation a little bit. I like to try to keep everything private, but this is one way we could do it. So that now we're just going to modify the tools, adding that new guy in. But what I'd much rather do is allow my superclass to actually do the real adds for us. So if I come up here and make this private again, obviously this is going to fail because I can't modify him directly. I'm going to come in and say super.add tool. So things get a little interesting in this scenario here. Let's tweak this. Let's see, what do I want to do with this guy? I'm going to get rid of this stuff like this. And let's make this be a safe toolbox. And let's have a safe toolbox.add saw and screwdriver. And the question of the hour, what will be called? Do I have enough visible here? I don't need this guy anymore, so I can reduce that. There we go. Okay, so let me put up my poll again here. So the question here is, at this line, line 37, what is going to be called? Go ahead and answer in the poll. Excellent, excellent. So everybody's saying A. That is very good because that is the right answer on this. And the reason for that is, once again, we look at the compile time type first. So what is safe toolbox? It's a toolbox. That limits the possible set of functions that can be called. So taking a tool and taking a screwdriver. Those are our only two options we can consider. We can't consider this guy at all because we don't even know that that's what safe toolbox is from a compile time point of view. So once we know that, we've now narrowed it down to toolbox. Now we're going to see the best fit for adding a saw to there. And so the only possibility between those two is going to be A. So A is that signature. Then at runtime, we say, okay, when we're making this call, what's the real type of safe toolbox behind the scenes? Well, he's a safe toolbox, okay? So then we're going to say, where is an implementation of add tool that I can use? The only add tool that's available to Safe Toolbox is the one that he inherits. Okay, does that make sense? Any questions on that? So now let's tweak him again. And the change I'm going to make here is to make the type of that guy be Safe Toolbox. If I do that, let's see, now I gotta get our poll come up here. Now it's going to be called. And everybody's saying C, correct. Because at this point, again, Safe Toolbox at compile time, we know he's Safe Toolbox. So we can consider all the functions inside Safe Toolbox, which includes the superclass functions. When we go to the compile time type of screwdriver, or saw, I mean, saw is what we're looking at, right? Yeah, so the compile time type of saw is saw. So here is the saw that we're actually going to end up using. Pretty simple. Let's do one more scenario here. Oops, I wanted to call that tool. And we'll make that be C, and we'll make this guy be D. And he needs to be open. Okay, so if I do this now, what's going to be called for saw? Let me redo our poll up here. What's actually going to get called on line 41? Good, good, good. So that's so I had a lot of them are D's. I did get a C. Um, D is actually what's going to be called here. So what's happening is at compile time, we look at the type of safe toolbox. That's going to give us our possible candidates for calls. So we're going to look for an add that takes a saw. So signature wise, it's going to be add taking a saw. Then at runtime, we take a look and say, well, what really is Safe Toolbox? Well, he really is a Safe Toolbox. So we're going to try to find which version of add saw applies for Safe Toolbox. And so that's going to pick D in this case. And then one more. This might be our last one. Whoops. What if I change this to be Toolbox? Let's take a look at this guy here. Those all look good. I'm going to end my poll and restart it. What do you think is going to be called now? So unanimous on this is C, and everyone is wrong. Let me run it just so you can see to make sure that this is actually gonna be the D one. We'll see that we called add saw adding safely. This is the one that usually gets people. It's an interesting scenario, but once again, if we walk through the steps, it should become a little more clear. So we'll start off, what's the compile time type of safe toolbox? Well, we know that it's toolbox, right? So we look at toolbox. These are our only options signature-wise. So here we're going to say which signature matches add saw. Well, it's going to be the one for C, right? So what ends up happening is in the generated class file, it makes a note that I need to call add tool. Sorry, add saw, because that's an option. That's an option we knew from that first one. So add saw is hardwired into the class file to say this is the signature we want. So then at runtime, it says, well, what really is safe toolbox? And so safe toolbox is, of course, a safe toolbox. And at this point, we want to find out which function that he has available to him matches that signature add saw. And the one he's going to see is this guy right here. And that's where things get a little tricky, is that we have this distinction between a compile time check for polymorphism and a runtime check. And the compile time check, all he does is make a note of that signature. At runtime, we double check to see, well, what is really available for that real object, regardless of the compile time type. It's actually going to look at the real type here. And this is kind of the essence of how polymorphism can actually be powerful, because we can resolve a signature up here, but end up overriding it and calling something else down here. The key here, though, is this means that if you want to refer to something by the supertype type and be able to use an override in the subtype, any of those functions that you want to be able to override have to be defined in the supertype. We'll notice how before, like an earlier example, we didn't have add saw. And if we just had add saw down here and only knew about the add in the only knew about add tool and add screwdriver at the toolbox level, we couldn't get to this guy. Uh, so if the compile time type was toolbox, it would only consider these signatures and not consider the add saw signature. Now that I've added this add saw signature to the supertype, it can be considered, locked into that class file that's generated, and then used at runtime and looked up. So this is where the scenario gets tricky. And this is where things like, if we got into a visitor pattern, for example, it would mean that you would have to define every possible type that you want to call in overriding your methods. And so it gets a little bit confusing there. But if you break it down piece by piece, first of all, what's the compile time type of the object that I'm calling a function on? What's the compile time type of the arguments? Match up what the signature looks like. And then at runtime, just see where in the hierarchy that function's available. You're golden. Make some sense? Any questions on that? Mhm. Exactly. Um, and if the subclass does define it, let's say both the subclass and the superclass define it like we have here, if we're referencing it via the superclass for the call, in that case, it can still call the subclass one like we've seen in this example. The place where it won't work is if, let's say, that this guy weren't there. So in this particular example, notice how override is being listed as an error because there's nothing to override. If I had this particular scenario where it's not defined in the superclass, what do we think is going to be called for this one? Let me do our little poll one more time. So if I had the code written like this, what should be called on 41? Good. Everybody's saying A. Good. That's exactly it. And what's happening here is the best we can do with taking the toolbox type, calling add with saw, the best fit is add tool. So it notes add tool in the class file that's generated. And then at runtime, it says, well, what really is safe toolbox? Well, the variable is actually a safe toolbox. What's his best fit for add tool? Well, this one isn't considered because it doesn't match the signature. We move up to add tool, and that leaves us with A. So these last two ones here, this is really why I like talking about this, because it's something that isn't really well known on how this behaves in Java or in Kotlin. And it's one of the reasons why polymorphism can be kind of tricky to use. And generally, I just prefer runtime type identification, which basically means that you would take a look at what something is at runtime and then do different behaviors based on it. I've done things in the past where I would create a function that handles each specific type, register it in a hash map based on the type of something, and then end up calling that explicitly, which can have some really interesting effects to it. Let me see if I can do a real quick version of that. I don't want to get too far down in the weeds here. Um, but let's say that we have our list of tools and we're going to have a list of adders, which is going to be a function that takes a tool and adds it to the toolbox. So the signature on this guy is going to look like I take a tool and I'm going to do something with it. But I want a hash map of those. Oh, I'm going to go in the weeds, aren't I? So I'm going to take K class and that. Yeah, this is going to go to a place where I really didn't want to go to. But I'll show you how, ooh, this is going to be real fun. And empty map. There we go. So I went into the weeds, didn't I? What an adder is he's going to be a function, a map of functions where I can say, based on the actual type of the tool, let me look up which function to use to add it to my toolbox. And, oh, actually, I need to go one step further on this. Ooh, pardon me for doing this. There we go. So it's going to be a function that takes a tool and then the list that I want to add it to. I'm actually going to say, oh, I'm not going to be able to do that. Well, yeah, let me do, ooh, this gets even more fun. There we go. Okay, so I'm going to look up which function to use. The function takes a tool and the existing list and then returns. Yeah, Louis, I'm with you here. Uh, then it returns the new list. Once I actually write the code for this, it might make a little more sense. I knew I shouldn't have done this, but let's just follow this down the path just for the moment here and see if this makes any sense whatsoever when I get to it. Because I like doing stuff like this. I think it's kind of cool. So I'm going to have a register adder, which is going to take a tool type, which is going to be a K class. I'm going to say star there. Yeah, I'm going to say star. I'm not going to try to go down that path with the generics at this point. And then takes in a function. And then this guy is going to say adders equals adders. Actually, I'm going to make this be a mutable map. So I don't have to worry about trying to do the whole thing there. I'll just say adders sub tool type equals adder. What does he not like about that? Really? That should be interesting. Is it going to let me do it this way? Oh, okay. That's the problem. I didn't define the actual type as mutable. I'm pulling back too much of the curtain here, and you're seeing the Wizard of Oz. So what this function is going to allow us to do is from the outside register in how we want to add something to the toolbox. So I'm going to get rid of these guys. And then let's say inside here, we're going to have a toolbox. And then we're going to register a few adders here. So we'll say toolbox dot register adder for saw class. And then here's how we're going to do our add. So this is going to take in a tool and the map, the list of tools there. And we're going to want to say tools equals tools plus tool. And what is he unhappy about here? Required list tool, returned unit. Oh, there we go. And oh, I need to define my add function up there in a sec. Okay, so that'll be good there, and I'll put a println calling saw adder. I'm really regretting this. And then we'll have a screwdriver. This is going to be one of those things that in 2 years, you're going to need to do something similar, and you're going to say, oh man, Scott talked about something like this. And you're going to come and find this in this video, and you're going to be like, Scott, you saved me. It's complex, but you saved me, and I understand it by now because I got through the whole class. Okay, so what I'm doing is I'm defining a couple functions here that these functions are just lambdas saying how I want to add something. And maybe there's something special it's doing at each of these points, but I'm just, keeping track of calling different adders for this. And so now we'll set up here and say add, taking a tool of type tool. And then I can say adders subtool class dot oh, because it's nullable. Oh, this gets gross. I promise you I will cover all of this stuff in more detail, but I've really gone way down the rabbit hole here. And what is he not happy about? Required list tool. Found, la, 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 la. Whoops, tools equals that, I should say. What is not going to happen? So, oh, it's nullable. Ah! And what is he unhappy about on this guy now? Required list found mutable map. Oh, there's the problem. Okay, so let's see if this works, and then I'll try to explain very briefly. We're going to get into a lot more detail, and you'll see exactly why this is. But I'm going to say toolbox.add that, toolbox.add that, and then we can print toolbox.tools. And my apologies for going down this rabbit hole. I shouldn't have indulged myself on this one. Okay, so let's try running this guy, and we should see calling saw adder, calling screwdriver adder, and then we have them both in there. Yay, it worked. This is how I might approach this in real life for a similar type of thing. Rather than using polymorphism or overriding, having a way of registering how to handle different types. I can look those types up through a hash map. So in this case, I'm looking up, based on the type of the tool, which function I want to use to add them, and then I'm calling that function. This is something we're going to talk about when we talk about nullability a little bit later. But basically what we're doing is we're saying, look up something. If we have a matching function, use it to modify the tool list. Otherwise, just return the original tool list and ignore this tool. And then take the entire result of this guy and assign it to tools. So my apologies for going down that rabbit hole. But this is a way that we can use runtime type identification to register and take advantage of uh, based on what something is. And I think it's a little more direct than the polymorphism because with polymorphism we had all those questions about which one is going to be called, and sometimes it wasn't super obvious. Once you're really comfortable with things like this as a type, uh, this will actually become a little more clear that this is actually one way you can do this very easily. Um, just as a note, this syntax here means I have a function that takes a tool and a list of tools and then returns a list of tools. So that's the functional type, and that's kind of the important thing to really get out of any of this is get used to this syntax for defining functional types. Um, my apologies for going down that rabbit hole. This will probably make a lot more sense maybe 4 or 5 classes down the line after you've done this more times, especially when we start talking about generics, and then I can actually specify this in such a way down here that we're restricting it to only being tools being used there. Um, okay, so I hesitate to say any questions, but if you have any questions, let me know. That's a good question. Um, this is something that I've seen done many times, but it's in some ways similar to a service locator where we're looking up something, but service locator usually has other connotations to it. But basically, what we're doing is it's I'd call it a function registry. I'm not quite sure what else to call it, but basically, we're just keeping track of a set of functions that are available and choosing one based on a type of something, based on a type of one of his arguments. And I've seen this done in several different places. I've done the same kind of thing for usually for like some user interface frameworks that I've written in the past. Uh, but yeah, this is one way you can register functions to do things for you. And it really starts showing some of the power of this language where functional types, especially being able to hold on to a function as a first class object is really fantastic. In other languages, before you had lambdas, well, in Java before Java 8, for example, you'd actually have to define objects. So instead of having this declaration, you'd have either an interface type there or a type of class that you would subclass normally. Um, but once you start getting comfortable with the way that functional typing works in Kotlin, this becomes a lot less cryptic. But it is something that when you first look at it, if your head's spinning right now, that's perfectly fine. That's perfectly normal. Um, and unfortunately, I stepped right into this one. I should never step into stuff like that because, hey, it's amusing to me, but it as somebody first learning a language, this is going to throw you for a loop. It's not something that you have to know about at this point. Okay. Any other questions? I'm just one of these guys that when I mention something, I like to give a little bit more on it if I'm not specifically thinking of talking about exactly this scenario later on. Uh, because otherwise people are like, "Oh, what was that you were talking about?" And then I try to do it over email, and then things are really bad. Okay, so we got that there. Let's see, what time is it? 9:36. We're doing pretty good on time. We got all that. Let's talk about properties inside classes a little bit more. So we'll come into this guy here. That'll be good. Um, when you're defining your classes, there's a bunch of ways you can define properties in it. We already saw some real basic stuff like here. So if I said class person1, inside here I could say var name, and I could say var age, something kind of like that. And then inside my main function here, I could have val person1 equals person1, and then person1 dot name equals Scott, and person1 dot age equals 57, something kind of like that. So this is a really simple way to use this. Anytime I'm using this dot syntax on an object, if I say dot something equals, I'm calling the setter for it. If I just use the dot something as an expression to get a value, then it's going to use the getter on that property. Now remember, when we're defining properties, this works exactly the same as it does for a top level property. You have a getter and a setter defined for this. If you don't explicitly define them, you get that for the getter, and for the setter, you get field equals value. And it's squiggling the get and the set here because it's going to tell us this is redundant. That's what the default is. If you don't specify get and set, you end up getting a backing field to hold on to the value, and then you represent that using the word field inside your getter and setter. If you explicitly define a getter and setter, and for both of them do not specify field, you don't have a backing field. Basically, those functions are just directly using the data. And most of the time, you'll use those for things that are read-only properties. So in this case, we're calling the set, and this one calls get. So fairly simple stuff so far. Probably makes a lot of sense here. What if we want to make sure that we have values when we're creating this instance? Because right now you see we're actually setting a default value for each of these that might not be useful by itself. So if somebody just created a person one and then used it, they're getting this blank name and this 0 age, which is kind of meaningless. So maybe we want to enforce that somebody has to pass in a name and an age. That's when we use a constructor. Now, there's two types of constructors in Kotlin, primary constructors and secondary constructors, surprisingly enough. So if I have person 2, I can define a primary constructor inline in the class definition. And that would look something kind of like this. Whoops. And age, comma, int. And so this primary constructor requires us now to pass in a name and an age when we create a person 2. So if I came down here and I did a val person 2 equals person 2, we'll see now that I get the squiggles and the parens because I'm not passing in values. This forces me to give some kind of a value when I'm actually creating this. I feel like I'm 576 sometimes. So we're getting a name and an age. So what do we do with these values? Right now we're ignoring them. If I had inside of here a var name and a var age, something like that, I still need some kind of default values for them. But I'm not actually doing anything with these. What I really want to do is set these things up. Well, maybe I want to let somebody on the outside still modify those. What I really want to be able to do is take the constructor values and assign them. And we do that in an initializer block. The initializer block has access to all constructor parameters. And so inside here, I could say this.name equals name and this.age equals age. The this dot syntax tells me I'm referring to the name that is owned as a property of person. So that's this name and age here. So I'm assigning them to the name and age that came in from the primary constructor. And boom, this gives us that construction. And it's a little on the gross side. I think these are probably because it's not used. Yeah, it's private because I'm not using it anywhere. If I came in here now and then I said println person2.name and .age, now notice the squiggles go away because I'm actually using those. I don't, it's not giving me that recommendation of making them private. But if I run this, I should see the Scott and the 57 coming out there with person 2. So this is one way we can do construction. Kotlin really likes to be terse about things. That's one of its big benefits. And this is pretty verbose. There's a lot of stuff going on here. So instead, what is a better way to do this, it's kind of a shorthand, is to take pretty much the same kind of thing we had up here, but instead put var or val right on it like that. And boom. Now what I've got is person 3 is defining the properties in the primary constructor. So now with person 3, I can come down here and the same kind of stuff will apply. Let me just give it a different name. I'll say Mike and I don't know, 22. And we'll make these both be person 3. And so now we should see Mike and 22 coming out of the last one. There we go. So this is a nice terse way of defining an object that actually has names and values in it. Okay, any questions so far? Okay, so let's see, the next thing I want to talk about in there. La, la, la. Oh yeah, so in this particular case, if you use these here, you can't explicitly define setters and getters. So if you wanted to override a setter or a getter, you'd really have to write something kind of like this. Make a note here. Must do it this way if you want to override get set for properties. Part of me wishes that they had given you the ability to go ahead and override getters and setters here. I think syntax-wise, that might have been super confusing to read. But at the same time, you end up having to get much, much more verbose if you want to end up using getters and setters. So this one here cannot override get set functions. Did that answer your question, or did I go in a different direction there? Yeah, sometimes that happens. I accidentally answer the question instead of intentionally answering the question. But that's actually a really good point. Is when you use when you define the properties directly in the primary constructor, you can't override the getters and setters, which is unfortunate. Okay, so let's see. Those are primary constructors. Now, a secondary constructor is sometimes you might want to have different sets of values. Um, if you wanted some parameters to be optional, you don't have to define secondary constructors. You could have, let's say that we wanted person 4 to have optional values. We could say the age is optional. And this allows somebody to create a person 4 with or without the age. So I can just come in here and, oops, did I just close? No, that's right. Okay. So I could come in here and say person 4, and that's still perfectly fine. Or I could create a person 4B with just the name. And optional parameters really reduce the number of different constructors you want. The place where a secondary constructor really comes in handy is if you have different subsets of data that you want to work with. So let's say that, what's the example that I used before here? La, 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 la. I'm just taking a look at an article I wrote to, come on, where are you? Wow, this article is long. Location. So that might be this might not be a great way to define a location, but let's just say, for example, that a location could be lat lawn or city, street, state, zip, something like that. So I might define a location, and there are much better ways to do this, by the way, but not a good location example, but good for data subsets. So let's say that I have a lat, which is a double, a lawn, which is a double, and a street, which is a string, city, state, and zip code, something kind of like that. So let's say that this is the actual data that I wanted to have in my location object, but I never wanted people to specify lat lawn along with street, city, state, zip. And I always wanted lat long to be specified together, and I always wanted street, city, state, zip to be specified together. So let's say that that's the constraints we're working at. We just kind of want one subset of parameters or another. What we could do is have secondary constructors to define subsets that must be specified together. Or maybe in this case, maybe you can specify lat lawn and all the others, but we want to make sure that if you specify lat, you specify lawn. If you specify street, you specify all four of those. So what we can do here is define a constructor that takes in lat lawn without saying val, something kind of like that. So what this secondary constructor says is you can create a location passing in lat and lawn, and then I'm just going to default the rest of the stuff. Or I can pass in the other four guys. There we go, something kind of like that. So this restricts how I can specify this. I either have to specify everything, or I specify just the lat lawn, or I specify just the street, city, state, and zip. So if we took a look at him down here, I could say val location 1 equals location passing in 1.0, 2.0, A, B, C, oops, and D. Location 2, I could specify just these two guys. And location 3, I specify just the other guys like that. So this is really the case where secondary constructors are useful for. And in this case, it has to be everything, the first two, or the last four. And so that's your choice on these guys. Notice that there's no code allowed in here. You can't tweak the code inside these. I could have expressions here that take the values passed in and modify them, create some other value out of them, and that'd be fine. But uh, generally, you can't do anything really complex with them. Okay, so that's one there. Let me actually rename that to location 1. And then we'll come in and create a location 2. Now, what if I wanted to have it be just the 2 or the 4? So I don't want somebody to really be able to explicitly call this. What I can then do is say private constructor in there. And that says that the only thing that can call this primary constructor is the class itself. So in this case, secondary constructors. So now if I come down here, and if I say, make these all be location 2s, oops. We'll notice that that first one won't work because I've restricted it. You can't call that primary constructor, but the secondary constructor is there. And so this is useful if you have like subsets that you want to call. You want to make sure that certain parameters are always called together. Okay, any questions on that? Okay, let me check something here real quick. I just want to check with the assignment to see if there was There it is. What types of things did I make you do? Okay. So I pretty much have everything that you need for the assignment. One other thing I'm going to talk about, because we're a little tight on time, I'm not going to hit everything I wanted to cover today. Um, but I do want to mention derived properties. Oh, did I talk about interfaces in here? No. Okay, good. So that I don't need that one there. But I do want to mention derived properties. So let's come into this guy here. Let's say that we want to have a property that's based on the value of some other properties. So it's completely generated. So if I have a person class, and let's say inside here I have a val name string and a val, let's actually say first name and last name, and then an age int, something kind of like that. So maybe this is my definition of a class that's going to have these properties. Note that they're all vals. I prefer this uh, rather than having things be modifiable. Sometimes you're going to have data types where it makes sense to make them modifiable, but as much as possible, try to have things so that the outside world can't modify them. Now let's say that I wanted to have a function in here that gives us the full name of the person by concatenating the first and last name. I know this isn't going to be, the best way to do it, looking at from a global point of view. But if we look at it just from real simple first name, last name point of view, what we could do is we could either define a function that says get full name and then say dollar first name, dollar last name, something kind of like that. That's one way to do it, right? What is he not happy about? Oh, let's say person derived one, something kind of like that. That's a weird way to word it, but this allows us to have a little main function here that's going to do a val person derived one equals person derived one, and then println person derived one dot get full name. It doesn't like my name. Oh, I didn't have age in there. That's what it doesn't like. There we go. Okay, and so if we print out the full name, we should see the name. And this is something you can do in pretty much any language. Oops, what is he not happy? Oh, that's that one I need to comment out. This is the problem with having so many files here. They all get compiled. There we go. So it printed out Scott Stanchfield. So that's one way to do it, but it feels a little awkward. I'd like to be able to treat this as a property so that I can just say dot full name. So what I can do is create a second one here. Let's create a person derived two. And instead of being a fun, let's make it be a val. I'm going to call it full name. It's a string. And because it's a val, the only thing that applies is a getter. So I can come in here and define a getter and just say, well, I could actually define it like this. Something kind of like that. And now I can create this second person. And instead of get full name, I just say full name, like a property. And this is called a derived property. And you frequently use these to take the value of something else and either modify it or combine values or do other things with it. Um, one of the places where I use it a lot is when I'm creating user interfaces on Android, where we have a model that's holding on to some data. And so the model holds on to it with a mutable type, but to the outside world, we want to expose it as an immutable type. So, changing the type of what you're seeing is another reason that this might be useful. Now there's a couple different ways you can do this. If I did something like this, what's the difference between person derived 2 and person derived 3 as far as full name is concerned? Any ideas? Well, in person derived 3, this one actually defines a backing field. So we're actually creating a string and storing it somewhere because we're not explicitly overriding the get. And you'll notice that this one here, he doesn't specify field. So there's no backing field here. The big difference on how these behave is this guy is every time you call it, it's going to recompute this stuff. In this particular one, he's computing that value once, which is fine because these are vals. They're never going to change, right? But this one, I'm recreating that string every single time. So let's see, string recreated every time. And then string created once. So depending on what you're doing, the initialization time for that, this is a one-time initialization. And if you never call it, you're taking a hit to not do anything. This is only called when you use it, but it's computing it every single time. Now, one place where that's super useful is if, instead of these being vals, if these were vars, now this one's a bit of a problem. It's a problem because if first or last name changes, full name doesn't. So what you really want in this particular scenario is to use that initial one that we had up here so that we're actually computing it every time. So good because first or last name can change, something kind of like that. Does that make some sense? Hopefully that makes some sense there. But these are different types of derived properties. Depending on exactly how they're set, when they need to be recomputed, how expensive the computation is, these are some different options for how you can uh, create these and manage these. Okay, any questions? I know we ran right up to the end here. Any questions on anything that we've covered? And I will double check that the assignment only covers the stuff that we did get to this week. We covered most of what I wanted to talk about. There's just a couple other little things I wanted to get into. But I went that one. I went down in the weeds on that one, and I apologize for that. So don't, if you didn't get what was going on in that last scenario, don't worry about it. It's something that by the end of the course, you probably will get. It'll probably look at it and say, "Oh, I get it now." Cool. Okay. Well, have a wonderful week. I will see you all next week.